So good day everyone, I'm Justin Cervera, a fourth year computer engineering college student. So this is digital signal processing. And so for the laboratory activity 5, the combined time and amplitude transformation of digital signal. So the objectives are to generate a discrete time signal using Python and to apply simultaneous time and amplitude transformation on a single input signal and then visualize and analyze how combinations of transformations affect the signal. So the background, the combined transformations. In DSP, transformations can be applied sequentially or simultaneously. So there are time transformation, shifting, reversal, and scaling, and also amplitude transformation, the amplification, attenuation, and inversion. So we need a computer with Python installed. We're going to import two libraries, the NumPy and Matplotlib. So if you haven't installed the library yet, do this. Do the installation first. So for the procedure and the code, so here it is. I'm using a Visual Code Studio as a compiler Python with Python. So first is, of course, import the required libraries, the NumPy and Matplotlib. NumPy as NP and for Matplotlib PLT. So this statement here is the discrete time index. So this statement makes a array of numbers from -10 to +10, increasing or with steps of 1. So this is for the original signal. We're having a single input, the original signal. Here, we make the original signal, and this formula here controls or manipulates how fast the wave repeats. So the NP dot sign, this makes the sine wave. So this statement creates a sine wave that goes up and down across the time values from -10 to +10, increasing by 1. This is used to plot the discrete time signal. The stem, it uses a vertical lines with dots to show each sample point. And this is the title. And for the plot label, X and Y label, to show the height of the wave. And for the grid, this adds a vertical lines. This adds a grid lines for reading the waveform easier and to show the plot. So these three here, this is the combined formula for the time and amplitude. So for the amplified and time shifted, so this is to amplify the signal and doubles the amplitude. And this one here is to shift the signal to the right by 3 samples. And for the attenuated and reversed, of course, the NP dot sign is to show the sine wave. So for the attenuated, the 0.5, this makes the amplitude half. And for the negative end, this reverses the signal horizontally. So for the inversion and time scale, so this -1 times the sine wave. This inverts the signal. The positive values become negative. And for the time scale, 2 times n, this scales the time multiplied by 2 and compresses the wave so it oscillates faster and more compact. So for plotting the waveforms, so the subplot, 3 rows, 1 column, and first subplot for the amplified and time shifted signal. So for the stem and for the attenuated and reversed, so subplot 2, and then this shows the attenuated and reversed version of the signal. So the title and for the plot label X and Y, and for the grid and subplot number 3, this is to show the combined inverted and scale. Also this letter K here to show the grid baseline in black color, and for the title the inverted and time scale signal, and the plot label X and Y, and then to show the plots. We'll run this code now, and we are given with the original signal. So here's the combined signals, the amplified time and the amplified time shifted, the attenuated time reversed, and the inverted time scale signal. So for the amplified and time shifted, the wave is taller and this moves to right. The jump reaches to 2, and then for the attenuated and time reversed signal, so this plots the amplified and time shifted signal, and also of course the title, the plot title and the plot label to show the height of the wave, and for the grid, and this is for the inverted time scale signal. This flips the waves upside down and compresses it. So that's the output. And after the procedure, the expected result should be the amplified and shifted signal is taller and shifted to the right, the attenuated and reverse signal lower in height and flipped horizontally, and for the inverted and the scaled time, upside down and compressed along the time axis. So here's the original signal, original input. So for the amplified and time shifted signal, here it is, and for the attenuated and for the inverted time scaled signal. So the guide question and for the conclusion. So in this laboratory, the results show that the signal may be moved and amplified, attenuated while reversed, or inverted while scaled, altering its appearance and placements to the graph. So that's all for the laboratory activity 5, the combined time and amplitude transformation of a digital signal.